this so I can see. So we'll be talking about biological corridors here on the Palouse and how us at PCD are starting to utilize these corridors within our work. We'll be talking about 4 points throughout this presentation. The first one is, first, what are biological corridors? Secondly, biological corridor design and how you can make them. 3, local wildlife that utilize them here on the Palouse. And 4, how PCD is creating biological corridors within our work. So first off, biological corridors. They go by several names: wildlife corridor, conservation corridor, habitat corridor, or a green corridor. You might hear them by all those things. It depends on what publication you're reading. And essentially, they're an area of connected habitat for wildlife populations that are separated by human activities or structures. Generally, they're also surrounded by human activity, structure, or land change. Biological corridors can facilitate colonization, which is the movement of species between different habitats. Nutrition, either for themselves, better diverse or more abundant food sources. Migration, which is seasonal relocation. Interbreeding, so they can find new mates, increase the gene pool, have better genetics. And reestablishment, when you want to increase populations and introduce new species. A lot of these can help prevent population decline from fire, disease, random events, inbreeding, infertility, or genetic isolation into subspecies. When one species has interbred too much, it now becomes genetically distinct from another species within its own genus. Additionally, without corridors, animals are forced to interact with people, and this can lead to conflict, death, injury, or on both sides for humans and wildlife. So first off, what are biological corridors? They can come in many forms. The ones that we generally focus on here on the Palouse are terrestrial landscapes. A good example of this is the European Green Belt, which is in Germany. It's over 8,500 kilometers long, and it extends from Finland to Greece. The idea of the European Green Belt came up in Germany shortly after the fall of the Berlin Wall. This corridor is located where the Iron Curtain used to be. Now, however, this area has been removed of fence, wire, and landmines and has a strong forest system of natural parks, and it connects the Baltic Sea to the Adriatic Sea. So this is pretty important throughout most of Europe on a vertical axis if you're looking at a map. Second, you can have marine corridors. Right now, there's a lot of legislation going through to create what is called a blue corridor, which is migratory paths for whales, where they'll exclude kind of boats, fishing, sound that can interrupt echolocation, etc. Marine landscapes can also include reef systems or protected island like archipelagos. The example that I have in this picture here is the Belize Barrier Reef, the largest of its kind in northern and western hemispheres, and extends for over 180 miles along the Gulf Coast of Belize. It's a total of 370 square miles, and it's a contiguous 4 marine reserves, 2 national parks, and 4 national monuments. The protections have started in 1966, so it's been around for a while, and Belize has a lot of pride in this particular reserve. Belize and Mexico are also working to connect their landscapes through Belize up through the Gulf of Mexico and then into like parts of Texas as well, because Mexico also has reef systems, but not quite as strong as the Belize Barrier Reef. The whole Belize Barrier Reef has nearly 450 mangrove keys and sandy islands where the reef in its atolls, and it's the largest in the Western Hemisphere. There are several, that would do that. Oh gosh. There's several endangered species within the reef system, including the American crocodile and the West Indian manatee. Other animals include sea turtles and the red-footed boobies. There's over 500 fish species within this reef and over 350 varieties of mollusks. Above water, this protects 178 plant species, and below, over 274 types of marine flora. So this one's a pretty big one. Biological corridors can also take place in cityscapes. A really great example is in Oslo, Norway. Recently, in the last 10 years, they've started a bee highway on top of their rooftops. The city of Oslo has determined that they are lacking urban parks, which means less plants for pollinators, and all the citizens are called to contribute by planting flowers, plants, and creating houses for insects on top of the roofs in order to provide them shelter and food along the city's areas. Green roofs, lush parks, and strategically placed beehives make it possible for the bees to find resting places and food almost anywhere in Oslo. So this has really helped with urban gardening as well. The fourth type of corridor you might see, we have these in Washington, are the bridge passes. This particular photo is from Banff Wildlife Bridges. The passages can be anywhere between 10 to 60 meters wide, and they're covered by local and native greenery. So shrubs, trees, grass, rocks, etc., that look pretty natural within the landscape. And they aim to introduce animals such as deer, moose, and bears to cross these bridges rather than over heavily trafficked highways. To date, the conservationists in Banff have documented more than 140,000 animal crossings along this highway, either through the bridges or through the underpasses. The fifth type you might see are called contiguous versus stepping stone corridors. So a lot of what we've done in the Palouse would classify as stepping stone corridors, but we're working more towards contiguous landscaping. These patches or stepping stones consist of approximately a smaller size and help with the dispersal of species, but sometimes you don't see species coming in and out of them as much as you'd like. There were a couple prominent papers in 1967. The biggest one was the theory of island biogeography. This paper uncovered how organisms respond to disconnected patches of habitat and what influences the diversity of number of species on these islands. Since then, this publication has had other principles applied to it on more terrestrial ways instead of just islands themselves, like surrounded by water. Now, if you're using it in a terrestrial landscape, it's called metapopulation theory. Overall, both of these papers explain how larger or closer connected habitat patches experience higher population numbers and overall greater diversity and lower rates of extinction. So this is really important for places like the Palouse, where you do have a lot of disconnected habitat based on like farmland or cityscapes around it. So now we're going to get into biological corridor design, which is part 2. There's no set strategies or parameters for biological corridor design. They can be affected by habitat, the desired wildlife species, species requirement, or spatial setting, land availability, human interference, among many other things. For the habitat, the extent to which the corridor will be used is dispersed by dispersers or traveling mammals, depends on the habitat within the landscape. The habitat within the corridor must be connected by high quality habitat that provides for the survival and reproduction of the targeted species. For desired species, the minimum corridor lengths and widths must be established based on the home range of whatever species you're trying to target. So if you're targeting a larger animal like a bear or a cougar versus some types of smaller mammals like rabbits or foxes or even bird species, you're going to have different requirements on how large that corridor needs to be and what's in it. If the corridor is to contain enough suitable habitat, then they can permanently occupy or travel within there more frequently. It's also important to align corridors with other suitable habitat for the species that are just native within the area. It was found that a lot of corridors include a variety of topographic positions like gullies, ridges, rivers, or even like snow habitat, supported a greater abundance of animals and have a higher rate of species diversity. However, you also have to think about human interference in all of these factors, because dogs, livestock, cars, towns, cities can all have a buffer zone and cause an edge effect, which we will also get more into. So based on this, there are 6 main principles that you can go by to create a decent corridor. The corridor should be as wide as possible. Wider is better. The rule of thumb is about a minimum of 1,000 feet. But like I said, it depends on the target species, but more habitat's better than less. They have to maintain as much natural and open space as possible next to any culverts or bridges that are designed for animals to go through. You want to encourage the use of these culverts or bridges by isolating the corridor and all the habitat around it. So essentially you're funneling those animals to go through these designated spots as opposed to roads. You want to maximize the land use adjacent to the corridor to reduce human impact. So this means you're trying to impede the movement and increase and decrease the harmful edge effect. You don't want to allow for housing or other impacts adjacent to the corridor. It's really nice to have some type of buffer, either through like a nature preserve or just like a field or grassy area. You don't want it like backed up into somebody's yard. You want to put easements close to prohibit access near the corridor. And you also want to develop strict lighting restrictions, ideally near houses or cities. This would mean that the lights are generally pointed down and not like skyward, like city lights. Light can be really distracting for a lot of different wildlife species, including bats or turtle populations, insects, hibernating animals, or birds. It can mess up a lot of their just natural honing devices, and it's not really great. And then they can wander into cities or just leave the corridor itself. So this is a quick table that kind of summarizes that. You see that the quality and size and number, the shape of the edge, and the position, these are all included in land classes or the principle of what you want to create. The site is really specific. Ideally, it should include some type of water course, because if you can't find water, a lot of your animals are going to leave. Linkages. So again, having a continuous corridor or contiguous corridor versus island effects creates a better population diversity, and they're less likely to move away and cause problems. And then you want to have a matrix, which is to integrate the conservation area with the surrounding land use. And a matrix also can include various types of habitats, which we had also described. So we had talked about edge effect earlier, and edge effect is essentially the result of an abrupt transition between two significantly different habitats. So this is a really clear example of an edge effect where you have a forest and the forest fire boundary. There's not a lot of transition. You leave the forest and then you are in this barren landscape that causes a lot of problems and can stress out animals. Another really great edge effect that you might see here is agricultural fields next to buffers or other protected areas. So ideally, you'd like to have a smoother transition. So it's just kind of more gradual. I'll show pictures of that. Less abrupt is better because they can provide physical barriers. It should be known that edge effects are not always man-made. They can be made by, in this example in the photo, fire. They can also be made by disease, light cycles, noise, drastic temperatures, elevation, like if there's a mountain range. You can also have edge effects in marine systems, like if you have like an extreme example would be like the Marianas Trench or like some type of dive down. So essentially too much edge leaves opportunities for invasives because, as you can see in this fire, there's not a lot growing here, and native species have a tendency to take longer to establish than invasive species. And if there's nothing occupying that space, then edge effect and invasives can easily take over. And that includes not just plants, but animals. However, this is not to say that all animals are bad with edge effects. Coyotes are a really good example of an animal that does fine. They don't care. They are fine with the edge effect. They'll just move through and they are very adaptable. However, a very close cousin of the coyotes, wolves, they don't do great with edge effect. They like their large homogeneous landscapes. So we're trying to minimize that when we create biological corridors. So this is an example of how to minimize the edge effect, where you have a deciduous forest that's gradually changing into a grassland as opposed to like a straight cut down the middle. Sometimes you'll have species increase or decrease, but it just kind of depends on what you're looking at. Species that thrive in this middle zone, this like transition zone, are known as edge species. A lot of birds are really great here. They do awesome. Raptors, songbirds, and small mammals, they have a tendency to do well. Ones that cannot transition are known as niche species, and they occupy a certain habitat or habitat layers. So a habitat layer would be like one tree, but it might occupy the shrub layer versus the canopy layer. Niche plays an important role in conservation. If we have to conserve species in its native habitat, we have to acknowledge the niche requirements of each species. If a habitat of a species is likely to address where it lives, such as a niche, it's thought of as like a profession. A niche is unique to each species and how they share that habitat, and no two species in a habitat can have the same niche. This is because it would create too much competition with one another, and eventually one's going to get displaced. So if you have two animals that are living in the exact same place, hunting the same thing, one of them's just not going to make it and they're going to have to move on, or that's how essentially natural extinction happens. So I had said with birds, a large number of different species of insects may be present at the same plant, but birds can coexist if they feed on different parts of the plant or they have a variety of insects to feed from. So that's how we kind of manage edge effect with gradual transitions. However, edge effect is not always terrestrial. You see it a lot in riparian areas. You see it a lot with amphibians. And this is kind of a broad example, but sometimes in riparian areas, you'll see a higher species diversity within that transition zone, because now you have upland or terrestrial and aquatic species all in the same spot. So you'll have frogs, turtles, or sometimes fish or small fish or other things kind of in that transition zone. So sometimes the populations can be higher in these areas. So in part 3, I'm sure everyone's very excited for this one, we will be talking about the local wildlife that utilize these corridors. So we have 2 different types of wildlife that can be in each corridor. You have resident species and then migratory species. Resident species that you might see on the Palouse include mule deer or white-tailed deer, coyotes, bobcats, badgers, river otters, or beavers. A hoary bat is a really great example of a bat species that you'll find around here, porcupine, or the tiger salamander. However, migratory species are ones that kind of pass through, and they might not be here full time, but seeing them isn't terribly unusual either. So cougars, black bears, wolves have historically been on the Palouse, but they're not here anymore. Moose, elk, snow geese migrate through, tundra swan, white pelican, and the northern hawk owl. So I have divided habitats that you might see on the Palouse into 3 categories, and we're going to go more in depth on these habitats and then animals you might see within them within these corridors. So we have grassland and shrub habitat, wetlands and wet meadow habitat, and riparian and forest habitat. It should be noted that a lot of the animals that we're going to talk about don't necessarily always stay within like that habitat that I'm talking about with them. Animals tend to move and they have different requirements. So I've just kind of placed them as best I can right now, but they migrate, they move around. So first off, we have grass and shrubland. The shrubland habitat in Washington is an arid landscape found primarily in eastern Washington, along with some other western states. It is one of Washington's most diverse ecosystems, and the shrub steppe provides habitat for species found nowhere else in the state, such as the greater sage grouse, the sagebrush sparrow, and the burrowing owl. With an estimated 80% of historic shrub steppe lost or degraded to development and agriculture since the arrival of non-native settlers, protecting the remaining shrub steppe habitats is more important than ever. So this is something that we've been tackling in our work at PCD. So we're going to go into some species. Typical bird species that you might see in the grassland habitats include red-tailed hawk, the harrier, the gray partridge, horned lark, vesper sparrow, western meadowlark, and the ringneck pheasant. Some other specialists that you might see are the chukar, the rock wren, and the common porwell. So the pictures that you see to the right are the northern harrier hawk. This is probably one of my favorite hawks that I've been able to see since I'm here on the Palouse. They're really diverse. They're really cool. We're going to talk about them. Hopefully they become your favorite hawk after we discuss this. Harriers breed in wide open habitats ranging from the Arctic tundra to the prairie grasslands to fields and marshes. Their nests are concealed on the ground, which is pretty interesting for a lot of hawks, in grasses or wetland vegetation. In migration in winter, harriers typically move south away from the areas that receive heavy snow. Harrier hawks have a tendency to fly low over the ground when hunting. They weave back and forth over the fields and marshes as they watch and listen. That's really interesting. They listen for small animals. They eat on the ground, and then they have a tendency to perch on small posts or trees or shrubs. On the breeding grounds, males perform elaborate flying barrel rolls to court their females. So you can notice that these harrier hawks are kind of, I call them the middle morph or the gray morph, but all of them are identifiable by the white spot on their butt or their rump, and then the black primary wingtips. Here you'll see the dark morph, but again, the white spot is still extremely visible. And then we call it the gray ghost, the white morph. So I've only seen the white morph once, but you can still see it by the black wingtips, the light underbelly, and then their faces, I think, have a tendency to be like a little flatter. And their faces are flatter because they have a facial disc, much like owls. So they actually have a stiff ring of feathers around their face, and that helps sound essentially be funneled towards their ear. So when I had said they listen for wildlife, that's how they're able to do it. So harriers are pretty cool. Horned lark. I really like these birds. They make me really happy when I see them in the field. They kind of look really grumpy because they're little horns and markings, but you can see them quite commonly here on the Palouse. If you look really carefully at bare brown fields, especially in the winter, you'll see them popping about. They're identifiable by their neat yellow face and their black mask and their tiny horns. Horned larks are widespread songbirds. You'll find them foraging for seeds and insects, and they sing a high tinkling song. Although they're still common, they've undergone a sharp decline in the last half century. Horned larks favor bare, dry ground with areas of short, sparse vegetation like sagebrush or bunch grasses, and they avoid places where the grasses grow more than a couple inches. The chukar is one of the specialists that you'll find in the area. Generally, you'll see them in the Steptoe canyons going down towards the Snake River. They were introduced from Eurasia, and they're actually the national bird of Pakistan and Iraq. They are a game bird throughout here and most of the world, but you can also find them in Hawaii and New Zealand as an introduced species. Its namesake comes from its calls that echo through the dry rocky slopes, and it runs and scampers up steep terrain with the agility and speed of a mountain goat, prompting many hunters to nickname it the devil bird for the brutal chase that they have to make after it. It's identifiable by the dark bands on its head and neck and its red bill. They live in dry country, so water is an important resource, and it takes advantages of all water sources, including river, ponds, springs, puddles, or even steeps that have barely moistened the ground. During the hot summer months, they seek out water, and you can find them in groups of 10 or more around these water sources. Despite their bold markings, the chukars tend to blend in with their rocky surroundings, so they're actually pretty hard to find. I know they're around, but I haven't even seen one yet. They're particularly wary and a bit shy, so they can take a bit to look for, and they have a tendency to run away immediately. However, your best bet to find them is from March to May, and it's a good time to go looking because the males are more likely to call from the prominent rocks and looking for mates. So another animal that you might see in the grassland and shrub habitat, these are all the mammals now. You just have a tendency to see more birds in some of those. Mule deer, badgers, the Nuttall's cottontail, white-tailed jackrabbit, black-tailed jackrabbit, coyotes, wolves historically, red fox, or elk. So the mule deer can inhabit areas east of the Cascades, but it prefers open forests and sagebrush meadows. However, they're also referred to as an edge species, meaning they can thrive at those interfaces where we were talking about where there's a lot of tree cover and then it gradually goes back into open plains. This allows the deer to feed in productive openings while being close to escape cover. The mule deer can move long distances during the spring and fall migrations to avoid snow. Mule deer summering in the Cascades migrate as far as 80 miles to reach adequate water range or winter range. Younger does have a tendency to only give out one fawn every spring, but when they're older, it's really common for them to have twins. The white-tailed jackrabbit. This species was very common across the extensive bunchgrass and grasslands of eastern Washington. But with the reduction of bunch grasses due to overgrazing, livestock, habitat loss, and fragmentation and competition, it's now pretty rare in Whitman County, but still around, mostly on the eastern side of the county. However, there is a large population in Okanagan. The white-tailed jackrabbits have a tendency to be nocturnal, especially when threatened or when numbers are lower. So they feed primarily on grasses and forbs and secondarily on shrubs. They prefer more hilly bunchgrass sites. So anything in the Palouse that has some bunchgrass and a lot of habitat, they would do great. However, in the winter, they descend to the sagebrush flats in the valley bottoms. They rest in the shallow holes that they've dug in the winter, and they create these cavities and tunnels beneath the snow. Because they're smaller, their home ranges can only extend about 1 mile to 2 miles in diameter. So you don't need a ton of space to utilize for white-tailed jackrabbits, if that's what you're interested in. Coyotes are a really great example of another edge species. In pioneer days, coyotes were restricted primarily to the sagebrush lands and brushy mountains and open prairies. But since then, they've really taken advantage of human activities and expanded their range throughout North America, way beyond. I think they're one of the most expansive animals in North America right now. In Washington, these intelligent and adaptable animals can manage to occupy almost every conceivable habitat type, from open ranch to densely forested to the downtown of Pullman and other waterfront areas. Despite the ever-increasing human encroachment and past efforts to eliminate the coyote, they have persisted. They have a tendency to eat small mammals such as rabbits, and you can find them easily because they have a tendency to be kind of messy eaters, and they scatter the fur around their feeding sites. Bone, feathers, and fur can be seen next to den entries, and signs of diggings occur when coyotes follow promising scents and excavate prey, including moles, voles, and gophers. I've seen a lot of coyotes actually follow tractors when people are harvesting their wheat, and they just kind of pick off moles and mice as they're running out. So they are really smart and they know exactly what's going on. However, they can also create a lot of conflict with humans. So it's best to avoid, enticing them into your area. They'll eat anything like vegetation, compost, fruit and bird seed, carcasses, garbage, or other small mammals, including your pets and livestock. So if you're interested in having coyote prevention, I can easily give you some good techniques on how to dissuade them from entering your yard. So next we'll be talking about the wetland and wet meadow habitat. A wetland is a distinct ecosystem that is flooded by water either permanently or seasonally. Flooding results in an oxygen-free process, especially within the soils. A wet meadow, however, is a type of wetland where the soils are saturated only part of the growing season. So in a lot of the wet meadows on the Palouse, here are some species you might see: wood duck, killdeer, Wilson's snipe, or woodcock, as we call them on the East Coast, marsh wren, red-winged blackbird, belted kingfisher, chorus frog, or moose. We'll be talking about the woodcock or the wood duck. And unlike most waterfowl, wood ducks perch and nest in trees and are comfortable flying through woods. Their broad tail and short wings help them maneuver through these tight spaces. When swimming, their head has a tendency to jerk back and forth, much like a pigeon's, but they are strong flyers and they can reach speeds of over 30 miles an hour. They're pretty identifiable. The males are very ornate, and the females have a small patch of blue and indigo with white primaries, but you can still see on the top of its head that it's got a little bit of a mohawk or a crest along with the white wingtips around its eyes. You can look for wood ducks in wooded swamps, marshes, streams, beaver ponds, or small lakes. They have a tendency to stick to the wet areas with trees or extensive cattails as a cavity cover or nesting habitat. Wood ducks will readily take to nest boxes. So if this is something that you're interested in, wooden nest boxes, they love it. And there's a lot of studies that show how well they use it. However, don't use plastic ones because they can get too hot and they'll overheat in the strong sun. The females will line the nest boxes with their down feathers that she's taken from her breast to help insulate her young throughout the seasons. Okay, so the belted kingfisher, another one of my favorites out on the Palouse. These are sexually dimorphic. So the female is the one with the little chestnut red band, and then the male is a little less ornate. They enjoy the edge of streams, lakes, and estuaries where they search for small fish, hence the name kingfisher. They'll also eat frogs or other amphibians if they can catch them. They fly down quickly and dive into the rivers and shorelines, giving loud rattling calls. They either hunt by plunging directly from a perch or by hovering over the water with their bill downward before they dive. Kingfishers live near streams, ponds, lakes, and estuaries, and they nest in burrows that they dig into the soft earthen banks, usually adjacent or directly over the water. Kingfishers spend winters in their within their nests, and the water doesn't freeze once it gets into the nest because they've built the nest kind of like slanting upward up the bank so they don't flood. They usually take 3 to 7 days to dig out their nest, but sometimes it can take up to 3 weeks. The completed burrow extends 3 to 6 feet into the bank, and like I said, it slopes upward. Next, we have moose. I'm sure everyone has seen a Palouse moose once or twice. I put them in the wetlands area, even though I know a lot of the moose around here are on Moscow Mountain or some of the more forested areas, but traditionally you will find them in swampy little estuaries. They're the largest member of the North American deer family, and the moose is unforgettable, either viewed from a distance or especially when encountered up close. Its sheer size commands respect, and its uniqueness makes it a curiosity. Generally, the moose prefer forested habitats where there are lakes, marshes, and other wetlands, and with its great size and foraging demand, the home range of the average moose in any given season is approximately 3 to 6 square miles, although they habitually wander much farther than that. Adult moose are nearly 6 feet at the shoulder, but I've definitely seen some that were much higher than that. And the bulls can weigh anywhere between 850 to 1,100 pounds. The females are only about 600 to 900 pounds. The adult antlers can spread anywhere between 35 to 50 inches, but they rarely exceed 55 inches across. The name from the moose comes from the Native American tribe, the Algonquin, and translates to twig eater. This is an appropriate name for these animals because they predominantly consume twigs, bark, and leaves of trees. In areas with abundant wetland, they will also eat the aquatic vegetation and the willows that you'll find. But in less wet areas like Northeast Washington, they'll eat the woody browse in the early stages of regrowth, especially following a fire, logging, or clearing instances. Moose are considered a pioneering type of animal, and they adapt to a variety of forage that will change seasonally. So if you have a moose coming into your area, that means you're doing something right. Next, we have riparian habitats. This is the last habitat type that we'll be talking about on the Palouse. A lot of our work is also within the riparian habitats. Riparian areas contain 2 types of elements, water and terrestrial ecosystems. The interactions between water and land create a unique environment that is critical to the survival and existence of land-based and aquatic species. Known for their moist and mild microclimates, riparian areas have fertile soils that enhance plant growth and support complex food webs. Riparian areas are a critical resource as they directly benefit numerous wildlife species, including many that we in Washington state cherish for their recreational and intrinsic values. So first, we have the Longeared Owl, which there are surveys for out here on the Palouse. I don't think they're as common, but you can do them with the Audubon Society. The yellow warbler, the lazuli bunting, violet green swallow, bobcats, cougars, beavers, otter, and porcupine. So here's the lazuli bunting. The male is the brightly colored blue one, and then the little female is the kind of tawny, plump one. The beauty of the lazuli bunting did not escape the early naturalists who named it, with its Latin name translating to beautiful sparrow. The male lights up dry, bushy hillsides, thickets, and gardens throughout the West, flashing the blue of a lapis gemstone mixed with splashes of orange. He belts out his squeaking and jumbling song from atop the shrubs to defend his territory. The softly covered female is often nearby, teetering on tiny stems in a balancing act to reach seeds. The stocky finch-like bird is related to the cardinals and the grosbeaks and often visits bird feeders throughout eastern Washington, especially those filled with proso millet, sunflower seeds, or Niger thistle. Most species molt their feathers on either the breeding grounds or wintering grounds, but not the lazuli bunting. After breeding, they start molting some of their feathers and then they migrate south to Mexico, where the insects are abundant following monsoon rains. Here they finish replacing their feathers with molting hotspots before they head farther south for the winter. Bobcat, probably one of my personal favorite mammals you can find out here in Washington. They're found throughout all of Washington and most of the United States and are probably more common than people realize. They appear to be using suburban settings more often, although due to their reclusive ways, they're not often seen. However, I will say that I have seen bobcat tracks out on Copple Farm, like the trail that goes along Paradise Creek. So they're definitely around. They have a tendency to travel in predictable patterns along logging roads, railways, and trails that are either made by people or other animals to move between resting sites and food sources or hunting areas. Evidence of bobcats' presence can include tracks of snow and mud, droppings, feeding areas, or claw marks on trees. So like most cats, bobcats have pheromone pads within their feet. So when they claw trees, not only are they helping to shape and sharpen their claws, but they're also leaving a scent trail. Adult bobcats can weigh anywhere between 20 to 30 pounds, and they're an average of 3 feet in length. However, the females are considerably smaller, and they can weigh about as much as a large house cat. They're identifiable by their ear tufts and their bob tail, hence the name. The home range of bobcats in the western Washington varies from anywhere between 2.5 to 6 square miles for adult males, and half of that for females. Females have a tendency to not travel as much because they have kits and like the babies can't move as far. They can inhabit anywhere between rock cliffs, outcropping ledges, and other important areas along the Palouse for shelter and raising young and resting sites. Large brush or log piles and hollow trees are often used in wooded areas. You can find bobcats in open fields, meadows, and agricultural sites, and however, their presence is not uncommon through brushy or timbered areas to escape cover. They occur less frequently in areas with deep snow because even though they are in the lynx family, they do not have the foot pads and hair between their feet like lynx, so they sink a lot more and their mobility is much less. Porcupine. In Washington state, porcupines occur in mostly forested areas, but they also thrive along the riparian zones in bushy wetlands or even in the shrub steppe regions of eastern Washington like Palouse Prairie. They have a tendency to den in those rocky areas along the prairie, and they're easily recognizable by a coat of over 30,000 quills. The quills are not present on their underbelly, face, and feet, which makes them vulnerable. These mammals can be mostly found in forested areas along Washington. However, they're one of the largest rodents in North America, second only to the beaver, and they can be difficult to find because they're nocturnal, and they have a tendency to spend most of their time in the same trees. Threats to these species include predators like fishers, wolverines, coyotes, and cougars. Fishers on the west side of Washington are one of the biggest threats to porcupine, and they can move up and down the tree trunks quite quickly and make it hard for the porcupines to escape. However, they have their quills for a wonderful defense. Humans are also a threat to these animals as they're considered pests because of their tendency to damage the trees and other leather objects. And like some mountain goats, porcupines are also infamous among backpackers because of their love of salt and the prosperity to eat road salt-covered boots. Lastly, because of their slow movement, their nearsightedness, and their nocturnal ways, they don't fare well on roads and have a tendency to be hit by cars and have fatal accidents. I know I've seen these also on the Paradise Creek Trail while I was biking, so they're definitely here on the Palouse. Lastly, how is PCD creating biological corridors? So the next couple slides are going to be fairly intensive with some maps, so I will try my best, but please, if you have questions at the end, let me know and I can clarify some things. So PCD's Big Dream, our pie in the sky goal, is to connect Smoot Hill with 4 Mile and Rose Creek Preserve to Kamiak Butte. Here's little pictures of each of them in order. And how we're doing that. Okay, first I need to have a huge shout out to Amanda Stahl from WSU. She helped us create a lot of these maps and charts. Along this chart, I know it looks like a lot, but I'm gonna help you describe it. We have 2 axes, the X and the Y. Y is vertical, X is horizontal. The X axis is the resistance to humans due to lack of vegetation. And the Y-axis is the capacity for corridor protection, with the bottom left corner being the lowest and the top right being highest, or farthest right being highest, depending on which axis. So essentially the areas in beige that we're going to look at on these maps have no potential at all and they're the lowest priority. These areas are degraded ecosystems, but they also have a low capacity for human cooperation. Areas in red have pretty low ecosystem, but a higher capacity for human cooperation. Areas in blue have coordination is low, so essentially it needs a lot of paperwork to get things done, but they have better habitat. And then areas in green are the ideal areas that we're trying to look for on the maps in the following slides. So this is all of Whitman County, and you can see there's a lot of red, which, as we had described, is good habitat, but really hard to work with. Poor habitat, but easy to work with. I'm sorry. Coordination exists and leverage is there, but ecosystems are highly degraded. So you can see that this is like a lot of the farming area. Blue is where coordination is low, but the ecosystem potential is much higher. Like I said, this has a tendency to do a lot more paperwork. Areas in black are already protected. So you can see right above Colfax, there's a little black dot. That's Steptoe. And then these other little areas in the bigger box. So Steptoe in the bigger box, you can see, here you go, here, Steptoe. This is Kamiak down here. And then this is Rose Hill, or Rose Creek and Smoot Hill. So we can see on all of these that the cost of utilizing some of this in blue is much lower. Habitat's pretty good, cost is low, but coordination is also not great. And then over in this corner, coordination gets a little higher, habitat kind of degrades, so it varies. So this is what we're looking to aim to connect here. So if we zoom in on it, again, we can see Smoot Hill, Rose Creek, and Kamiak over here. Everything in green are very high natural areas that have a potential for restoration and also have a potential for prairie remnants. So you can see that it's surrounding Kamiak Butte. You can see some surrounding Rose Creek, and you can see some surrounding Smoot Hill. Areas in light green are where there's still vegetation at the end of the growing season. And then areas in translucent white, like these lines here that you're seeing, not the roads, that's a road, these translucent ones. These are potential riparian corridors. So our idea is to potentially connect all of this, you can see along the riparian corridors and along these habitats to create a really nice contiguous and not island or spotted corridor on the Palouse. So we're working on that, and it's just going to take some time, but we did put in our first proposal this year. So this year we put in an FY23 grant. It's called the Partnership to Restore the Riparian Areas in Lower 4 Mile Creek Watershed. Our proposal, we haven't got this grant yet. We just submitted it in September. So everyone keep your fingers crossed for us. Our proposal is to restore over 30 acres of riparian area along 4 Mile and Rose Creek watershed. So all of this is the Rose Creek watershed. We will be working here along this stretch where you can see the little stars and some of this greenway. This is the Rose Creek Preserve. And then we'll also be working a little bit up here. So restore over 30 acres of riparian areas. We'll install over 600 feet of stream bank protection, along with 10 to 12 beaver dam analogs. They're kind of like fake beaver dams that we use to increase riparian health. Provide technical assistance to landowners in the area, provide vegetation monitoring, and install new interpretive signs. And lastly, develop new curriculum on restoration and conservation agriculture. So this is what we're working towards. It's phase 1 of our larger landscape project. A quick example of what one of those project sites would be. So again, like one of the project sites would be like one of these stars. Zoom in a little farther. You can see the riparian area here that we would be restoring all along the edge. This buffer will probably be around 30 to 50 feet, depending on what the habitat next to it is like. But that's just a good example of what we're trying to do in that area. I think we're at time. So I know this was a lot. It was a whirlwind, but does anyone have any questions? Thank you for listening.